All right, guys. So this is the video for completing your dissolved oxygen test. This is one of the most important tests that we can do because as we're finding out, dissolved oxygen is going to be one of the biggest things for any aquatic organism. Uh, Anything that does cellular respiration, we need oxygen. We need that gas exchange. If dissolved oxygen gets too low, that's not good. Okay, so with our Hawk test kits, okay, you guys are going to get really used to going through these, looking at these things. At first, it's a little bit overwhelming, but you just got to go slow, really try and read the labels. Unfortunately, on a lot of these things, they're getting pretty old, and you can see that the labels aren't that easy and great to read. So we'll try and work through some of these together. If they say pH, that'll be like pH indicator. But just do the best that you can. Uh, and when I get back next week, we'll go through all of these. Okay, so I wanted to walk you through the dissolved oxygen test first, get you guys practicing this. Okay, so very first thing in this manual. Okay, this is where all the instructions are. Be careful with these. If pages are loose, really make sure that we don't lose them. You can tell they're getting a little bit beat up. You know, we take them out in the field with us. We want to be as careful as we can, make them last as long as we can. Okay, so in the manual, you'll go through and you can see that each one will have the heading of what we're trying to test. Okay, so we're looking at dissolved oxygen. Now, one thing that kind of helps too is at the end they give you an item list or an apparatus. Okay, or it says reagents and apparatus. This is everything that you'll need in this test. So it's sometimes a good job to go through that. Anything with the asterisks down here, those things aren't going to be included in your test kit. You don't necessarily have to have those. We have all the stuff right here, so we'll go through the stuff that we have. Okay, so first thing, if we go through that, we're going to need our bottle with the glass stopper. Okay, got clippers for clipping off one of the pillows of our reagents, 100 milliliter graduated cylinder. You need your titration device. Okay, and then what do they call these? Delivery, or not the delivery tube, um, cartridge. Yeah, it's a digital titrator cartridge. So that's what these are. So this is going to work with our digital titrator. And so those are the cartridges. Okay. Then it says we need our oxygen number one. So you can actually see there, it'll tell you dissolved oxygen number one, right? The bag is also labeled on the front there. Just got to be really read the labels, okay? Number two, number three, and last, our starch indicator. Okay? So first thing you do, you can pause the video if you need, go through, get out all of these pieces. Okay. So Now, now that you have all of those, you just start at step one. Some of the directions are a little bit funky, kind of hard to interpret. But the big thing that we need to do first is we want to collect a sample and test dissolved oxygen. So now we don't want to be dunking this in, trapping air bubbles in there, shaking it around, things like that, because we want to try and get um, results that are reflective of what we actually see in our fish tanks or out in the field. Okay, and that can be a little difficult with running water. They talk about that, how to do that in here. We'll go over that before we go on our field trip. But basically, we just want to just gently fill it up all the way with this glass stopper. It's pretty neat. As long as we kind of overfill it, put it in gently. You'll see it doesn't trap air bubbles too much. So you guys are going to be testing using our aquarium water. So we'll look at this aquarium that we just cleaned last week. Whoa, there we go. And so when I do this, we don't want it to bubble glug 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 too much. So we're going to hold it sideways, and you just want to let that water just kind of gently flow in, right? And just kind of allow it to fill and let all that air escape out of there. Okay. So once it's in there, you can kind of move it around. Okay, it's good. You can see now that I don't have any trapped air bubbles in there. Okay. And so as I take it out, you can see that it also, we have extra water in the neck there, and that's okay. And so what we're going to do is we're just going to take that stopper, and this seems weird, but we can put it in there and it's going to overflow. That's okay. because we just don't want to add any extra oxygen. Now this is the crazy part. Ready? Oh, it stays in there. Okay. So now we have our sample. We're ready to go. So that's first step. So we fill up our 60 milliliter glass collection vial. So now next thing we need to do is we want to add in our reagent number 1 and reagent number 2, and they're nice with directions, and they tell you that you kind of want to get the stopper in there and get them mixing quickly at the very end. So you're reading through how to do this, you add these and you keep reading, and all of a sudden you waited too long. So it's kind of, you want to add them in, get the stopper back on, and then mix it up before we allow too much to settle onto the ground. Okay. So all you have to do for these, sometimes if you kind of go like this on your thumb, that moves some of that reagent down into the bottom to where it's not flying everywhere when we tear it open. Okay. Tilt you down here so you can see. Go ahead and take this off. And the big thing is we just want to go slow with that stopper to where we're not forcing more air into our sample, changing our results. Okay, so just try and get all of that in there. Okay, and do the same thing with number 2. Okay. Okay, and now we'll start to see kind of some of these kind of crystals form. Ooh, see, that was bad, forcing air bubbles in there. Okay, and then we're going to turn it over a couple times like this. We really want it to mix up. Now what you'll see is on the bottom, they'll say that fog kind of forms. That's okay. That's pretty normal. But we can kind of mix this up a little bit. You don't want to be shaking a lot, but you can already see I kind of goofed up there, and I got some bubbles in the top. That's what you kind of want to avoid, is you don't want to have bubbles, because now as I agitate this, that's trapping oxygen in there, and that's actually going to increase our results for dissolved oxygen, just making it not quite as accurate. So that's kind of actually what you want to avoid. Okay. So then it says we want to let it stand. Okay. So it says we have this nice line here, and we want to allow all this to kind of settle out until the top is completely clear. So I'll pause the video, come back whenever it's nice and clear. Okay, so now we can see that this is called what they'll call the floc, F-L-O-C on there. So we want that to settle out, leaving it mostly clear up here. Then it says, okay, let's go ahead and invert that again. Okay, and so we're gonna mix it up one more time. We just want to make sure everything's mixed in well, and then we're gonna wait till it clears up again. And I'll be right back. All right, so now we can see our sample is looking pretty good. Everything is settling down at the bottom. So now it says go ahead and use your clippers. This is going to be our dissolved oxygen packet number 3. So we just want to clip that off at the top. Okay. If you can, this would be in a pain. Wow, exciting footage right here. Okay, so this stuff, it's kind of chunky, so you got to work it out of there a little bit. So again, just with the stopper, we want to be real careful, trying to keep all that water in there. That way we get a nice, good, airtight seal. Okay, and you can see it kind of drop that down in there. Let's see if you can see this. And then what they said, what's going to happen is that our solids down there, they're going to start to actually dissolve, which is kind of cool. So that you want to make sure this is completely empty. Okay, and then again, we just want to be very, very careful putting that lid in there. Just slowly put it down. Oh, that was a better seal. Okay, so now that we don't have air bubbles. Okay, and then we're going to turn it over several times. Okay, and that'll start to dissolve that floc. Okay, then what we're going to have to do is after this is all nice and dissolved, should be this nice kind of yellowish color. Okay, and we're going to pour off 50 milliliters. Okay, so this is a 60 milliliter sample bottle, so that's going to leave us with about 10 milliliters in here, and that's where we're going to begin our titration. Okay, so as I'm doing this, if you haven't taken chemistry, a titration We see them a lot with pH. Basically, we are going to add in a certain amount of reagent, and when we see a color change, that's an indicator that we are balanced, and then that allows us to say, hey, we know how much reagent we put in. That tells us we know then how much it requires to balance that out. And that's how we can use titrations to figure out all sorts of different things. In this case, we're going to be looking at dissolved oxygen. Okay. So now, once you got that pretty well dissolved, you'll see some small flakes. But overall, now that flock is pretty much gone and dissolved. Okay. So now, you can go ahead. Remember, we have with a plastic graduated cylinder, we're not going to have that meniscus. So we're just going to fill that up to that 50 milliliter mark. Okay. Okay, get down nice and low. Make sure we check. And again, with these guys with such small samples, the more accurate we are, better, because any small change, even if it's like only a milliliter off, that's going to really affect our results. Okay, so now we get to start to look at this digital titrator. Okay, so that is this bad boy here. So how this works, okay, a couple things is as you spin this, what's going to happen is it's going to force this plunger on the end out through our discharge tube, and that's going to drip solution into our sample. Okay. Now, as we turn this, you can see it counts up and it keeps track of how much we're using. Okay. And this is going to be really important. This is going to be the number that we use when we actually calculate dissolved oxygen. Okay. Now, if we need to reset it, try and get it for the lights right here. If we need to reset it, that front knob, you just turn it, okay, and it'll start to count up. Look at that, boom, 0. Okay, so that's how we reset it. Now, you might notice this little guy here. You want it pulled all the way back when we go to put in our cartridge here. So this just slides in. Before I get too crazy, it says we wanted the sodium thiosulfate, okay, the 0.025 N. Okay, so just make sure you have the right stuff. That just slides in. Now, instead of twisting this thing all the way until this goes out, what you can do is push down on it and slide it forward until it is firmly in there and you can't slide it forward anymore. Okay, now take off the cap. Whoa, a little too far. That's okay. So we want to bleed off any air in there. So we don't want any air in our sample. So what we can do is we can slide that up again if we want. Okay. And then we can also use this and twist it until we can see that all those air bubbles are out. So that way we don't have any funky results. We can continue. And once you get it to flow out just a little like that, should be good. Okay, and then we can just kind of wipe off the tip. And then now we're ready to start with our titration. Okay, so now this is going to be the sample here that we're going to titrate. So next step is we want to add 2 drops of our starch solution. So you'll look on here and it should say starch indicator solution. Okay, so what's going to happen when we do this is our sample will turn into a nice dark blue color. Okay, so we kind of swirl that around. Okay, now when we do our titration, what it says in the book is we're going to continue to add our sodium thiosulfate until our solution turns clear. Okay, so before we do that, we always want to make sure we reset before we begin our titration. Okay, make sure we get it to 0. Okay, and now we begin turning the dial up top. Let's see if I can get this all in the picture. Whoa. Yeah, baby. Okay. And you'll begin to see that start to count up. Okay, and then you should start to see drops drip into our solution, and we're wanting that solution to go completely clear. Okay, so keep twisting. Now, they do talk about a discharge tube for this. We don't have any of those. So it's kind of a little bit funky. We don't have it going right into the solution. But as you add these, you should see it starting to lighten up a little bit. We definitely don't want to go over. Okay, so you just keep adding drops. Okay, give it a little swirl every now and then. Close. One or two more ought to do it. Oh man, how exciting! And there we go, like magic. Okay, so now you can see our solution has went completely clear. So we are now balanced. And we have a reading here. It says 464. Okay. So last step, number 12 says, okay, read the number on the digital counter window, divide it by 40. So we're going to do 464 divided by 40. Which gives us a dissolved oxygen of 11.6, which I think might be a little high, but we did just change the water in that tank. It's a little bit cooler than it normally is, so that could be. So it gives us a reading of 11.6 parts per million. And that's your dissolved oxygen test. Okay, now one big thing as we go to clean up this test, we don't want to, especially if we're using this stuff with fish tanks. Again, we just talked about no tap water. I have some distilled water jugs here for you that'll be labeled. We're going to rinse that out with, or deionized water. Rinse that out with deionized water. There shouldn't be any chlorine, anything like that in there. We'll rinse, this bottle out, and the same goes for when you're out in the field doing this. A big thing is before you collect your samples, you want to actually rinse your equipment with the water you're going to be sampling. That way, you don't have any residual anything from your previous tests in there, and it's rinsed with the sample that we're going to be collecting. That's going to give you your most accurate results. Sorry, the video is a little slow there in the middle, but practice, do the best you can, read the labels.